So, good morning everybody. I hope you had a very great opening of JFall earlier this morning. It was an enthusiastic thing to be part of, and now I'm standing here and I'm trying to be as energetic as I can. All right, that's not completely true. I can be way more engaging. Let's see. So, nice to see so many of you here. My name is Maarten Mulders. I work at InfoSupport. We're a software consultancy firm here in Veenendaal, close by. And I mainly work with clients of us as an architect. So that's why we are discussing an architectural topic today. And we're going to discuss Dapr. Now, in my role as a consultant, as an architect, there's one thing that gets me up in the morning. And some of you that I've worked with earlier may recognize this: complexity. That's what makes me tick. Solving complex business problems is what I like to do. But when we speak about complexity, I must make a little nuance. Because to me, there's two types of complexity. The first time is the essential complexity. This is complexity that is inherent to the business domain we're solving, to the business problems that we're facing and that we're asked to address. That's the interesting part. The stuff that I like a little less is the accidental complexity. Complexity that's there because somebody chose a particular framework to use, or because they want to show off how smart they are as an engineer. Look at me, I can write this very complex code. Isn't it amazing? And that's the type of complexity, by the way, that usually bites you in the ass later, because then you're looking at your code base and you're like, what's going on here? What is this code supposed to do? And it holds for code, but it also holds for architectural choices, so the bigger picture, so as to say. Now, as I said, essential complexity, I'll have it for breakfast if must be, but this accidental complexity, that's something, if possible, I'd like to get rid of it. Now let's look at a simple Fixtures architecture. Imagine we're building this new system for a client of ours, or maybe we're just doing an in-house project, and we know we need to scale out to infinity and probably beyond. So we already envisioned that we have a couple of instances of our application, 1, 2, how many, I don't know, and we know that somewhere we will need some kind of a caching mechanism or a key value store. It could be used as a cache, but it can serve different purposes as well. So we go to the whiteboard, we start drawing, it looks a little bit like this, and within a few minutes we're probably facing the question, okay, this key value store, that's nice, but what are we going to use for that? I mean, if we have one application instance, not big of a problem. We can use an in-memory map maybe, if it doesn't need to be persistent. And if it must be persistent, well, then maybe we should just write it to disk or something. Simplest solution first, please. We can always make it more complex later if we really must. So, simplest solution, but yeah, we already know we need more than one application instance, maybe for availability reasons or for scaling reasons, whatever. So we need some kind of distributed key value store, and yeah, then what's that going to be? Are we doing Redis? No, somebody will yell, PostgreSQL, it can solve everything. It's the most powerful database, and I don't think they're wrong, by the way, but that's a different story. Or maybe Hazelcast, or hey, we're running in the cloud, why wouldn't we go for Azure Cosmos or AWS DynamoDB? So many choices, but what are we going to do? And if we're looking at this question, I'm reminded of this picture of myself, which is actually in our headquarters. So I'm basically quoted, for those that do not master Dutch, as saying, architecture is all about making choices, but let's not rush. Let's make the choice as late as possible. If we can postpone, let's try to do that. All right. Interesting, thought-provoking maybe. But going back to this one, is this a choice that we need to make right now? Can't we postpone that one? Can't we just say we have a distributed key value store without knowing exactly what's underneath it? That would be great, wouldn't it? But that poses us with a challenge, because is there any standardized API for a key value store? Yeah, sure, there's the map interface in Java, of course. But that doesn't translate into a PostgreSQL database or something. Ports and adapters may be of use, but still we are, at some point, tying our application, using an SDK to, is it Redis, is it PostgreSQL, is it Hazelcast, whatnot. We are introducing a dependency at a stage that we would rather not yet do that. So if we could just find a standardized API for that. Now, if you are working in the Java ecosystem for a little bit longer, standardized APIs, to me, that makes a bell ring. And it's actually the dinosaur in the room, the Java 2 Enterprise Edition. It dates back as far as 1999. To be honest with you, I wasn't even working with Java back then. We did have a computer at home, but I wasn't programming it yet, I think. But Jakarta EE, as it is named today, has always strived to provide these standardized APIs, you know? You don't have to care about whether it is a MySQL database, an Oracle database, a DB2 maybe, because we have JDBC, the Java Database Connection. And same for instance, for message buses, there's a standardized API for that as well in Jakarta EE, and lots of other topics that we can just access over a standardized API without having to know explicitly what the underlying technology is. It's a relational database, it's a message broker, and that's all we need to know. So, that would be cool, but then look at the typical deployment picture of a Jakarta EE-based application. We have our application code, which is there, it's the little block. And then we have a lot of blocks around it, because the application needs to be deployed in an application server. The application server is running inside the Java virtual machine. The Java virtual machine is deployed in a Docker container probably, and eventually the Docker container is running somewhere on a hypervisor. That's a lot of abstraction layers for something that was supposed to be simple at the start of the day. And don't get me wrong, I'm not blaming Jakarta EE here. That's absolutely not the purpose of this talk. It's a very powerful platform, that's for sure. But this is not precisely the type of abstraction I'm looking for. Can't it be a little simpler? I'm asking the question again, just to be sure. Can't we make it simpler? And this is where I would like to introduce Dapr to you, the Distributed Application Runtime. It's a project initially started by Microsoft, and just the other day, it entered the CNCF, the Cloud Native Compute Foundation, as an incubator project. So that means they're transitioning into a more open governance model where Microsoft is not precisely the only one that is making the decisions. Still, there's a lot of involvement from Microsoft, but they're not the only ones anymore. And Dapr claims to be an event-driven, portable runtime for building microservices on cloud and edge. That's quite a mouthful. We'll see in a few minutes what that actually entails. But the interesting thing here is event-driven and microservices, or as I prefer to say, distributed architectures. Because that leaves us away, that brings us away from the discussion about, is it microservice, is it nano service, is it macro service? Because yeah, the code base is growing a little bit big, isn't it? The thing that really unites them is the fact that we have one solution which is split up in several runtime components that somehow communicate with each other and work together to perform a task. So what is inside the Dapper Box? I've called this ingredients, or well, if you're feeling funny, you could say it's kind of a buzzword bingo, because everything is there. I mean, it's open source, yay! It's polyglot. Ooh, who doesn't want to be polyglot these days? By the way, it's modular. We like modularity. It's pluggable. You can plug in new stuff. Who doesn't want to do that? And of course, it's cloud native. All the buzzwords are there, aren't they? Little disclaimer, there may be traces of nuts, gluten, and other allergens inside as well. So let's look at a more serious level at Dapr. Dapr consists of building blocks. And those building blocks are really the foundation of what Dapr is all about. Building blocks describe cross-cutting concerns that may appear in distributed architectures in a standardized way. So one example of a cross-cutting concern would be the thing that we just saw. Hey, I'd like to have a key value store. I don't care about what key value store, how it works, I just want key value storage. And it exposes those building blocks using standardized APIs. And the standard that they chose to build upon is plain old HTTP. That's cool, because it means that you can basically connect every program to a Dapr foundation as long as it speaks HTTP. And there may be some programming languages out there that do not speak HTTP, but I'm not 100% sure if you would use those to write enterprise software nowadays. So any more or less serious language does have HTTP connectivity inside. And let's look at the key value store. I've got a small example here. What we see is that we do a post to an endpoint, state vehicles. We pass a piece of JSON, which is actually the entries that we would like to store. They are identified by a key, which in this case is a license number of a car, and we'll see in a minute in a quick demo why that is. And a value, which is again the license number, and a timestamp at which the vehicle entered the system. And the response that we will get is 204, no content, saying, yeah, sure, 200 range, everything's okay. I don't have anything to tell you, because yeah, you gave me something to store, I stored it, no need to talk any further. The interface is small. There's no needless exchange of passing back the data that you just gave me. That's all for performance reasons, as we will see. And similarly, if I want to retrieve something from my key value store, I can do a get to almost the same endpoint, passing the key as a URL parameter, and then I will get back the response, in the response, the value that I've just stored. So far, so good. This is key value storage in a very simple way, exposed over an HTTP API. I have to add, by the way, there's also a gRPC version, which you can use as well, but I'm looking at HTTP here because it's just prettier to read on the screen. So, how does that work? Let's get back for a second. We're connecting to localhost 3500 over there. Why is that? What's running there on localhost 3500? Well, that is our sidecar. The Dapper sidecar, to be more precise. So what we see if we are going to start working with Dapper is that we have our application depicted on the left, and it communicates with the Dapper sidecar over either HTTP or gRPC. And the Dapper sidecar, as I mentioned before, is built up of all those building blocks. And there are many more, but we'll see them in a few minutes. Now, this is the standalone version, the standalone deployment, if you wish. If you are running in Kubernetes, then you can also deploy this sidecar as a separate container inside your pod. So your pod will consist of a number of app instances and a sidecar to which the applications will connect. And together they form the pod, and Kubernetes will take care that when the app is running, there's also a sidecar running. And the communication between the app and the sidecar remains the same, HTTP or gRPC at your choice. Looking at this sidecar a little bit more detailed, we find that it exposes a standard API. We already saw that, it's up there, it's the building block that has an interface, HTTP, gRPC. And inside the building block, there are those modular, those pluggable components. And if we look at the state store, for instance, we will see implementations based on Redis, based on Hazelcast, based on PostgreSQL, and all those other options that I've already mentioned. They're all baked into the sidecar. So the sidecar is a powerful beast. It knows a lot. It knows how to talk to all those underlying systems. But the good thing is, my application does not have to know this, because it only needs to know the HTTP interface. if you're working in Kubernetes environments, in distributed systems, you may be familiar with the concept of a service mesh. A service mesh also works with a sidecar. The sidecar that will intercept all connections, maybe add tracing, maybe add failover and retries and that kind of stuff. And if you look at the Dapper sidecar, you could say, well, isn't that a service mesh as well? And I would say, no, it's not. It's a service mesh, but on steroids. It's better. Why is it better? Because it doesn't address connectivity issues per se. It raises our abstraction layer. It addresses application concerns rather than infrastructure concerns. So instead of saying, hey, I would like to have a reliable connection from A to B, it offers me the possibility to say, give me a key value store, because that's the only example we saw so far. So let's look at it in practice. I have a very small demo with a key value store, of course. Let's see. Now, this is the exciting moment. Is it going to work or is it going to fail? Dapper is already started. And here I'm starting the sidecar, the Dapper sidecar. And when it starts, it will also run my application. And the first part looked good, but then I saw some errors, I believe. Let me double check. That's all fine, that's all fine. Why is that? Dapper D exited. That's not what I was hoping to see, of course. Then probably this isn't going to work either, but let me double check for a second. No, that's not working either. Let me try again just to be sure. It's a computer after all. Did you try turning it off and on again? No, I did not. Maybe it's because I don't have a Wi-Fi at all. Could that be an issue? Just to be sure. Not the best network, but at least it is a network. Of course, I'd love to. If only you'd let me. You know what? Hotspot ready. While that is loading, let me quickly discuss what I was about to show you. If you're Dutch, then you may be aware of this trajectcontrole thingy. And if you're unlucky, not in a positive way. The idea is relatively simple. We have a piece of highway. There's two cameras, one at the start, one at the exit. As soon as you drive past the entry point, your license plate is registered by a camera. If you drive past the exit point, same thing happens again. And the system can then calculate how long did it take you to get from A to B. We know the distance between A and B, it's 30 kilometers. We know it took you so much time, so we can calculate your average speed and we can determine if we are going to surprise you with a nice speeding ticket or if you obeyed to the law and you will not receive a speeding ticket. That's the idea. And the architecture would look like this. That's a car in between, by the way. Two cameras. And they both send the pictures of the cars to a traffic control application, which will measure your velocity. And if it exceeds the limit, it will inform the fine collection application, which just collects the whoever needs to receive a speeding ticket. But to get the speeding ticket to your mailbox, we need to know whose car is that. So that's why we have a vehicle registration system where we can do a lookup based on the license number. We can verify who's the owner of the vehicle. Let's take the other Wi-Fi in the meantime. Let's try once more. No errors. I think it was the fact that my machine was unconnected to any network. once more. Fingers crossed this time. I know I have a little bit of time to get the demo right. Yes, this looks fine. So let's revisit for a second. What are we doing here? The first thing is, and it's up there, we're saying Dapper run. Then we say app ID, which is the logical name of our application. It's the traffic control system. We're saying it exposes an HTTP API on port 6000. And we are telling the application, if you need to communicate with the sidecar, you can do it over HTTP on port 3600 or on gRPC, over gRPC on port 60000. And we're passing a folder where we can find the Dapper configuration. This is because we're running in standalone mode, and the configuration is not available in a Kubernetes cluster. Then finally, we have -- Maven Spring Boot run, which basically starts our application. Now, if we simulate an entry of a car, there we have it. As we can see, we are saying port 6000 entry cam, and we're passing a piece of JSON there. On lane number 1, we found a car which has the license number XT346Y. And this is the timestamp when they entered the piece of the highway that we're measuring. Great. Now, if we would look in Redis, which is our the key value store that we chose first, I'm entering the Redis CLI here, which gives me a way to look inside the Redis store. We can say, what is it again? I need to look it up. Yep, like so. We can ask which keys do we have available. And it says traffic control service. Well, that's quite a lot already. hgetall, traffic control service. And then we have the number, which was XT346Y. And there we have it again. We have exactly the payload that we've submitted earlier, the license number, as well as the timestamp when they entered the system. And now if I would do an exit, basically the same thing happens. And if I would look up the same entry in the key value store, I see it has been updated because now I have an entry timestamp and an exit timestamp. Given the entry timestamp and the exit timestamp, no speeding violation has been detected, so the system doesn't do anything else than this. Well, the fingers crossed emoji was definitely needed over there. But eventually we had it working. Great. So far so good. What we've seen that we can use a key value store, which is Redis in this case, without our application having to know that it is using Redis. I'm not going to run through the code at this point, but at the end of the talk, I will give you some pointers where you can find the code and you can inspect for yourself. It doesn't know about Redis. So far so good. We've seen building blocks inside the Dapper sidecar. We've seen components implementing those building blocks. Let's see what other components we have, because until now I've only talked about key value store, and maybe by now you're like, yeah, I got it already, I can do key value store, but hey, is that everything Dapper does for me? Because that's quite an overhead for such a simple concern. You'd be right, by the way, if you'd say that. So the key value store, let's skip that one. Another component that Dapper offers is service invocation. So rather than my application needing to know where a different system lives, what its address is, I could invoke a REST endpoint using Dapper by pointing at its logical name. Remember that app ID that I gave in the demo? It's told Dapper, hey, this is a traffic control service. Any other component, any other application living in the same Dapper installation would be able to invoke endpoints there by asking for the traffic control service, just by its name. And this is something that you may have by default in Kubernetes as well, if you configured it correctly. But if you run standalone, you don't have that. You need to know the exact address, or maybe even the IP address of a machine where a different component lives. You don't need to if you're running Dapper. There's pub/sub. So rather than me needing to know upfront who wants to know about speeding violations, I can publish an event. And I could say, hey, I've detected that somebody drove too fast. And I don't need to know who needs to know about this, but everybody who's interested can subscribe. And whenever I publish this event, this fact that happened in the world, you will be notified and you can do with that information whatever you need to do. It's asynchronous. Of course it's asynchronous, but the good part really is this decoupling of sender and receiver. Sender doesn't need to know who will be receiving. Receivers don't need to know who is sending. It's completely unaware of each other. Bindings are a very powerful building block as well, because they provide interfaces to the outside world. There's quite a few bindings that are available by default. You can think of sending messages. You can think by email or by using Twitter even. But there's also incoming bindings. Wait, I'm going to do this a bit faster because I have pictures for one of them, for each one of them. This is an interesting thing to mention, by the way. There are already over 27 different implementations of all those components. For each of the building blocks, you have multiple options how you want to implement it. So, service invocation, that's what I just discussed just yet. Very simple, synchronous request response, blocking if you wish. But no, it's not blocking by default, by the way. You can block on it, but it's non-blocking by default. Pops up, where one application sends a message, publish it to a message bus, and many applications can consume that fact, but they don't need to know about one another. Bindings, and that was when I remembered, wait, I have pictures of this. I'm sorry for that. So bindings allow my application to interact with the outside world, for instance, by sending out email messages, by invoking web services that do not live in the Dapper installation. But there's also incoming bindings. For instance, you can define a cron binding, which lets you write an expression and say, hey, I want a particular endpoint of my application to be invoked on a daily basis at 10 o'clock in the morning, for instance. And sure, you can do this with many other frameworks as well. Spring will let you do this. But then your application needs to know about it. It needs to know, and it needs to manage the schedule itself. And if you are running multiple instances of that application, you need to be sure that not all of them are doing it at the same time, because it's a batch process and it needs to run only once. And before you know it, you have a lot of additional complexity. Accidental complexity, let's be honest. This is not business complexity, this is accidental stuff. I don't want to care about it, actually. MQTT, both incoming and outgoing bindings, and the list goes on and on. Secrets, where we have, if we have a secret store available, we can retrieve values from that secret store, where we know it will be stored in a secure manner, not accessible to people that don't need access to it. So, let's see a few more of these building blocks in action. Invocations and output bindings. We're looking at the same architecture here. It's still traffic control systems. And as I already mentioned, what we will be doing, once a speeding violation is detected, the traffic control system will just send out the event. Whoever needs to know about it, somebody trespassed the law. And then the fine collection service will be like, hey, I need to know about this. Let me handle this. It will ask the vehicle registration service by looking up the license number and getting back information about the car owner. And then it will send an email, which is an email binding outgoing. So we need to start a few more applications this time. We already had the traffic control service over here. I can keep that one running. This is the fine collection service. And starting it is basically the same story as we saw just yet, but with different port numbers and a different application identifier, like so. And then finally we have the vehicle registration service, which will expose information about owners of a car. And now we are going to run a little helper program, which is a simulation, which will just randomly insert cars into the system. Some of them will drive too fast, some of them will not. And it will publish that as little messages on an MQTT broker. And there we see it already. We see that cameras have been started and entries and exits of vehicles are being simulated. This is a simulation. It just acts as if there are cars. Let's look at our traffic control system. Hey, that's interesting there. Speeding violation. That car drove 15 kilometers per hour too fast. Let's make sure that they receive a fine for that. This is the fine collection system, which does the lookup of the license plate, finds out who is responsible for that car, and then sends them an email saying, hey, you've got a fine, and this is the amount that you need to pay. Here we have a mail client, and what we can see is that indeed we have an email sent. They're all being delivered to the same mailbox, obviously, because it would be a bit hard for me to show to you that it works if it's just random email addresses. And we see the license information about the vehicle, and we see when the car was detected as being driven too far, and the fact that they will be fined with 130 euros in this case. And if we're lucky, we might even have, yes, we even have somebody who really drove very fast. It's so fast that the system says, hey, I don't know, I have no rules for this, but the prosecutor will get in touch with you and tell you what you need to do. You might need to go to the judge even, but yeah, that's a different story. So we saw a lot of building blocks in action here. And the interesting thing, again, I would like to stress that, is that the application code base doesn't know about all the underlying technology. It doesn't know about MQTT, it doesn't know about which SMTP server are we using, it doesn't even know about SMTP. It just knows that, hey, if I invoke this HTTP API, pass it a certain JSON payload, an email will be sent for me. And that's all it needs to know. So, there's another topic I'd like to discuss with you briefly, which is observability. If you've ever worked in distributed architectures, you may be familiar with the concept. For who is this a completely new topic, observability? Can you please raise a hand if so? Sure. In a nutshell, to me, observability is about being able to observe, hence the name, what's going on with my system in a production environment. And there's two pieces of observability that can be very valuable. The first one is tracing, which allows me to make sure that, to visualize in a way how a request is being handled from the very first system that receives it through my whole landscape, what other systems are involved, what other methods are being executed elsewhere, and very important, how long does it take? Because this allows you to troubleshoot the fact that a consumer may say, hey, I'm invoking this endpoint of your system, and it takes ages to load. Okay, but we are in this distributed landscape. What is exactly taking ages to load? Well, that's where tracing can be of help. And the second one is about metrics. And metrics are basically numeric observations about what my system is doing. They're not about a particular request or a particular invocation of a method. They're about things that have happened in my system. How much of the CPU are we using? How much memory are we using? Those are operational metrics, and your system administrators will be very happy if they have actual insights on that. But there's also business metrics. How many clients have signed up today? Or how many clients have disposed of their account? How many clients have we said goodbye to today? Two types of metrics, and there's a lot more to tell about it, but that's not the scope for today. Looking at tracing, what you would typically do if you want tracing in a distributed architecture, you would start injecting headers into each and every HTTP request, or if you're not using HTTP but something else, you would be injecting headers, and those headers would be collected by some kind of a collector to build up the trace of what has been going on when handling that particular request. There are standards that describe what header names to use and how the values should look like. But doing this may be quite a lot of manual work. And of course, there's libraries like OpenTelemetry that can help you do this, but still you need to be aware of it. And now when we're running in Dapr, it would be pretty cool if we could do the same thing. So if we could actually make, for instance, a call to a get value from a key value store, also visible as part of that trace. Maybe that's where the performance bottleneck is after all. And luckily for us, Dapr does provide that. So it will take its part in a distributed system, and it will happily propagate those headers for you. And if you would collect them using Zipkin, which comes with Dapr out of the box, you would get nice traces like these, which show you, hey, there's a call that entered the system, it was handled there, the system then did a lookup in the value store, it then invoked this other system, which did a lookup there, which did everything. But I have to make a little disappointing statement here. It doesn't yet work for Java. Of course, we could be very skeptical about this and say, well, what would you expect from something that was developed at Microsoft? I'm not here to preach hatred against Microsoft. But I was very disappointed when I found out about this. And I think, to be honest with you, that's quite a deal breaker if we are building distributed systems and that we do want to have tracing. And if it does not work out of the box, well, I'm not sure if I would go that way. But if you would be running a .NET solution, they have it built in they have it built into the SDK basically. So yeah, tracing is a very powerful thing, and I'm already pondering my brain like how would you solve it in Dapr for Java. I don't have the solution yet, but I'm pretty sure they need to address it some way. Metrics then. Technically speaking, Dapr doesn't care about what your application metrics are. It doesn't care about your Kubernetes metrics like resource usage. But what it can do, it can expose metrics itself. So how many times did the sidecar crash? Or well, let's assume it didn't crash. Let's just assume it runs happily ever after. How much calls did it get and how much calls did it send out? What is the memory usage of the sidecar process itself and whatnot. So from an operational point of view, it does expose quite valuable metrics, but it will not give you business metrics because Dapr is not about the business logic after all. That's what your application code should be focusing on. And then those metrics can be scraped by a tool called Prometheus and eventually be visualized in tools like Grafana. But then again, that's really out of scope for this talk because you could build a whole talk around that topic alone. But just know that if you are running Dapr, you will be able to receive metrics from the sidecar as well. Oh, there's a few more metrics that I forgot about. And eventually you could build dashboards like these, which show you how Dapr plays its role in your total infrastructure. So about this tracing thing that I mentioned before, as I said, you would usually pass on a bunch of headers, and Dapr would actually appreciate if you could also pass on an xDapr request ID header. It's not mandatory, but yeah, makes things easier on their side. And now this introduces an interesting question because my application should focus on business logic and not on accidental complexity, as I mentioned in the beginning. But really, knowing about these kind of APIs, isn't that essential? Is that essential complexity? I think it's not. This is accidental complexity. This is the kind of stuff that I'd rather not know about, right? Well, the good part is you don't have to. You can. As I said, Dapr is primarily exposed using HTTP and gRPC APIs, which allow you to connect from any platform. But for quite a few popular platforms, they provide SDKs already. So for Java, for instance, you have the Dapper SDK for Java, which is published to Maven Central, as you would expect. And rather than having to know the details of that HTTP API for a simple key value lookup, or a simple method invocation on a different system, you can use a Dapper client provided by that SDK and say what you want to do. For instance, hey, I would like to do a call to the vehicle registration service. This is the path I would like to have, vehicle info plus the license number. I'm not passing any request body because it's a GET call, as the next line says, and I expect to get back an object of type vehicle info. And this SDK will then take care of knowing exactly what the endpoint is, passing on the necessary headers, and I believe, but that's my personal opinion, it should also take care of propagating that tracing context. That's what you would expect in such a product. But then again, for Java, it's not there. For the .NET SDK, for instance, it is there. It will read the tracing context, it will propagate it back to Dapr without you having to write a single line of code. That's actually the type of integration that I would love to have in my hands, but unfortunately, I don't have it. So, it's time to get back to our original question. Is Dapr a dinosaur? Is it a reincarnation of the Java 2 Enterprise Edition platform? 1999 on the line, they would like to have their platform back. Or is it maybe a developer's dream come true? Finally, the tool that saves me the headaches of building distributed architectures. Well, if you've listened carefully, you'll have noticed it's not exactly the same thing as Jakarta EE. Jakarta EE abstracts technology, databases, message brokers, web services, while Dapr abstracts concerns, application concerns, without having to know the underlying technology. Also, Jakarta EE requires you to write in a language that runs on the Java virtual machine. Java being the most obvious choice, but I think you can write Kotlin or even Scala if you are feeling adventurous and make use of what Jakarta EE has to offer. While on the other hand, Dapr says, I don't care what language you're using, as long as you can talk HTTP or gRPC to me, I'm totally fine with it. So I'd say that one's busted. Dapr is not a dinosaur in a fancy suit. But then, is it a developer's dream come true? Is this the thing that we should all be aiming for? Should we immediately start rewriting our existing distributed architectures to leverage everything that Dapr has to offer? Well, shouldn't come as a surprise either. I think you shouldn't be doing that right now. There's quite a few things that I feel are lacking, tracing being the most obvious one for now. Also, if you are already running a distributed system, many of the concerns that Dapr will take away from you, you will probably already have addressed. Maybe you're using a library like Hystrix, or what's that Twitter one again, Finagle, which takes care of kind of these problems. Moving to a new platform that does the same thing is not going to offer you a lot of value. I don't really believe in these kind of, hey, let's do a technical migration from A to B. What business value does it offer? Well, 0. How much time does it cost? Well, a lot. I don't like that. I would have a hard time advocating that one. So, is it the developer's dream come true? I'd say, again, that one's busted. That's not yet, at least. Maybe for a greenfield project, if you're feeling adventurous, if you're doing polyglot because you also want to do things with .NET and whatnot, maybe, but not tomorrow. So we're almost at our time. There's a few takeaways I'd like for you to remember when you leave the room. So what is Dapr all about? It's about building blocks for distributed architectures. that take away some shared concerns that you may have. Second is that it is all powered by a sidecar architecture. Sidecar will take you to places that you haven't been before because it will relieve you from the concerns that you would used to have in your code bases. But finally, Dapr is not a one-stop shop. It's not your Swiss Army knife. I'm sorry for all the Swiss people in the room, but it's not going to solve everything. Very simple example. Yes, you can connect it to PostgreSQL, but you cannot run an arbitrary SQL query on that database. You can only do a key value lookup, that's all. So with that, if you are interested and you want to get your hands dirty, there's a Dapper Workshop that you can run. You can do it in your own time and figure out yourself. I've got some pointers to documentation to get you started, and you can just explore the world of Dapper for yourself. But there's also a step-by-step guide. So it's 7 assignments, and you can do them. You can also follow the step-by-step guide, which will tell you exactly, hey, change this piece of code because it will do that and that, and then run it in this way, and you will see that and that, and that's how you can verify that it worked correctly. And with that, I would like to thank you for your time. If you've got any questions, feel free to raise them right now, or see me around at the venue. I'll be here for the whole day. There's at least one question there. Yes, please.
Just wondering, if I followed it correctly, how about Dapper being, stand next to console or Istio? What do you feel about that?
Console and Istio are basically service meshes, right?
Yeah, so the binding part is, I think, the extra, if I'm wrong. But do you think it's something is comparable compared to console or Istio, or it's still not that mature?
I think they're not. I think Dapper is addressing different questions than console or Istio. If I don't know them that well, but as far as I know, they are focusing on infrastructural concerns, connectivity, maybe unreliable connections, that kind of stuff. Whereas Dapper takes your abstraction level a bit higher and says, hey, I don't care about the underlying connection, I just want to achieve a certain goal. Invoke a method, send out an email, or be triggered by some kind of schedule to get started and do some work. So I would say they address very different concerns. Would that answer your question? Yeah. All right. Yes, please.
Comment on that. There's a really interesting talk from DapperCon about the man group case. There they actually integrate with console. And there's a really interesting talk about this, how they see it as a complementary thing.
Oh, that's a good one. Yeah. That DapperCon was just 2 weeks ago, I believe, and if I'm not mistaken, the talks are already available on YouTube. So, yeah. All right. Any other questions? All right. Then thanks again for your time. Have a wonderful JFL. Enjoy being with other people, and see you around. Thank you.